Hi, everybody. In this video, I'm going to talk about the integration techniques again. And we are going to learn the integration of expressions involving square roots. So we are going to have one special example where we will apply substitution to integrate the integral. So let's see such an integral. You see integral square root a squared minus x squared dx. So we are going to do the substitution, and we are going to prove this uh, difficult looking formula. However, you will see that it's not so much difficult if we follow the steps and if we do the right substitution here. So first of all, let's try to understand under root expression. So it's a squared minus x squared. We can do some other techniques here, some other applications, but I'm not sure whether they are going to take us to a relevant place. So we have to be sure that we will get some function after the substitution. We are going to get some function out of the root. So this is very important because it's better to get rid of the root here, because as long as the root here, it will make some difficulties to us because we have no other choice than making here the relevant substitution. So now let's try to this time try to apply substitution using trigonometric functions. So let's try to apply x equals a cosine, or maybe let's take sine, a sine. Actually, it doesn't matter. We are going to get this to the same thing, but it's better to use a sine t here. So we are going to make such a substitution here. Of course, we have the term dx here. It's going to be dx del of x, differential of x is equal. You know what is differential here? It's a sine t derivative in respect to t dt. So this is equal a cosine t dt. So beware of that. If we have done the a cosine t substitution, then we are going to deal with some negatives, which we should avoid in these cases. So a cosine t dt. Now let's simplify our integral. So it's going to be a squared minus x squared equals. So we have here, you see, a squared minus, instead of x, we are going to use this substitution, a squared sine squared t. So we are going to apply our knowledge here. So a squared knowledge from school years, 1 minus sine squared t. So we know that it's going to be a, actually from under root a squared, we are going to get absolute value of a, but we are going to talk extremely on positive values, either for the functions and for the a here. A is given positively here. So we get a times under root cosine squared t, which is obviously a times cosine t. So we have here such a simplification here, and dx gives us a cosine dt again. So let's place everything here in its place. So after we place it, we are going to get a new integral after all these substitutions here. So we have a, so we are going to get integral a cosine t. So no need to write it again here, because we have already done the expression here, a cosine t times a cosine t dt. So it's going to be integral a squared cosine squared t dt. And obviously, we have here square of cosine t. So it's something we can do. We can integrate already. There is no problem for us. A squared times cosine squared t dt. Of course, we are going to use here the formula for half angle, or how we can say sometimes double angle. So cosine squared t, we all know that it's equal to 1 plus cosine 2t divided by 2. So let's place everything in this integral. We are going to get equal a squared times 1 plus cosine 2t divided by 2 dt. So it's going to be 1 out of 2 we can factor out from integral, and it's going to be integral 1 plus cosine 2t dt. So we have here again a squared divided by 2 times, using just our primary knowledge of integral, it's t plus 1 out of 2 sine 2t. 1 out of 2 sine 2t plus c. So you can see, comparing here our original integral, we have the variable x, but in the final integral, we have the variable t. Of course, it's better to, not always, but it's better in our case to come back to our original variable x. How we are going to do it? We are going to start from here. So we are going to work back. That's why it's called back substitution. So we know that x equals to a sine t, a sine t. This is our substitution. So sine t is actually x divided by a. So why we do? Because first of all, we are going to be sure about this t here. So we are going to express t and sine 2t with x's. So sine t equals to x divided by a. So we know it is t equals to arc sine x divided by a. So t is okay here. We have already done this t. Now let's try to find sine 2t. So sine 2t, we know the formula for double angle. It's going to be 2 sine t cosine t. So it's equal 2 times, well, sine t, we said that it is x over a times, and cosine t is actually, it will be, we know how to deal with these cases, 1 minus, so you know, 1 minus sine squared t. So let's write here cosine t is equal under root 1 minus sine squared t. But sine squared is x divided by a, so it's going to be x squared divided by a squared. Just very little simplification here will take us to the 1 out of a times a squared minus x squared. Okay, so 1 out of a we factor out from out of the root. So we have a squared minus x squared. Of course, we can go forward. It's going to be 2x divided by a squared under root a squared minus x squared. So I suppose we are done with all this stuff. So what we intend to do now, we are going to write our final answer. So everything here, our integral will be integral a squared minus x squared dx equals. So let's write what we have. Again, a squared divided by 2 times. Instead of t, we agreed that it is a arc sine x divided by a plus. So you can see here 1 out of 2 times sine 2t we have already expressed. So it's going to be 1 out of 2 times 2x divided by a squared times a squared minus x squared plus c. So we can do what we can do here. Actually, we can do some simplifications here. I'm going to delete the uppercase here, because upper part here, because we don't need this part anymore. If you are not sure, you can go back in the video, scroll back and just check again. So it's equal. So we multiply here, it's a squared divided by 2 arc sine x divided by a plus. So we multiply here, obviously these 2 and 2 are cancelled. So what we have here finally, a squared is cancelled with this a squared. So we have x divided by 2 under root a squared minus x squared plus c. So let's check our original integral. We said that our original integral should be something like this. You see, it's exactly the same that we have received here. So again, what we have done done here, actually we have used some substitution which is called trigonometric substitution. It's useful in these cases. And we can also use this trigonometric substitution with other case. For example, let's suppose that we have such a function, a squared plus x squared. So integral such an integral dx. Here it would be better if our integral includes such a radical. So it's better to substitute this x equals to a tangent t. Okay, we can have something different. For example, let's suppose we have integral x squared minus a squared. It is completely different here. So we can also do x equals to a times secant t. So what does it mean? It's a function which is a times 1 out of cosine t. So we can do these substitutions there. Of course, in each of these cases, we are going to do some geometrical and trigonometrical simplifications. We are going to use some trigonometrical identities that we already know from school. They will be useful here. So I wish you good luck with these integrals, and do not forget to follow our videos in our YouTube channel and share them. And also don't forget to share your questions if you have, in case you have these questions, do not hesitate to ask. Thank you very much for watching. Hope to meet you in our next videos.